Okay, sometimes they flip this around, and what they do is, instead of getting you to work out the maximum kinetic energy at the bottom, and therefore the maximum velocity at the bottom, they get you to work out the maximum height. It's the same idea, but it's flipped. So if an object is thrown up in the air, so me throwing this pen up in the air, when it leaves my hand, it has its maximum kinetic energy. So if I throw this pen up in the air, for the moment it leaves my hand, it's just as it leaves my hand, it has maximum kinetic energy. There's no other force pushing that up anymore. From that moment, the only force acting on it is gravity pulling it down. So its velocity will decrease, but its height's increasing. So the kinetic energy is being transferred to gravitational potential energy. When it reaches its top, its maximum gravitational potential energy, that can't be any bigger than the maximum kinetic energy it had at the bottom. So it's the same idea. We say the kinetic energy when it took off is equal to the maximum possible gravitational potential energy at the top. And then, as I'm going to show you, you just rearrange the gravitational potential energy equation to find the height. So, first of all, I've got in my case, a cat. 10 kilogram cat, that'd be quite big, wouldn't it? So, you've got your object, 10 kilograms. It's going, when it leaves the ground, at 30 metres per second. So the first thing I've got to do is work out that kinetic energy here. So again, kinetic energy, half times mass times velocity squared. So I've got that at that point. So plug my values in, 0.5 times my mass, 10 times my velocity, 30 squared. I always do that because I get the values just for putting them in. So putting the values in, substituting the values, you get a mark. So I put that into my calculator, so 0.5 times 10 times 30, press the squared button, and I get 4,500 joules. So that is the kinetic energy the maximum kinetic energy when it left the ground. So we say that that is equal to the maximum gravitational potential energy at the top. It cannot be any higher than that. That is the maximum it could possibly be. Because energy cannot be made or destroyed, it can only be transferred. So that energy has been transferred from there to there, and if it's maximum, that's what it can be. Now, I just rearrange my equation again. So, just rub this off. If I know my maximum gravitational, I know my gravitational potential energy at the top now. So, gravitational potential energy is equal to mass times gravity times height. So I put my values in. Before I rearrange, I substitute the values in because I get a mark, and if I make a mistake rearranging, I still get that mark. So my mass was 10 again. Gravity, in your exam, it's going to be 9.8. So it'll always be 9.8, that's what the spec says. You might look at old exam papers, old exam questions, and it'll use 10. With the new syllabus, when that came out, they changed to the more accurate figure of 9.8. So 9.8 newtons per kilogram times the height we're trying to work out. So this time it's a lot simpler because we've got no squared, we haven't got any square root. So it's just times on this side, it becomes divide. So 4,500 divided by 10 times 9.8. Put that in brackets. And this will give me my height in metres. So put that into my calculator. 4,500 divided by bracket 10 times 9.8, closing bracket. That comes out at a height of 45.9 metres. So quite a way, quite a high, quite a height that got to. So again, it's this simple idea of they will give you, like in the previous one, they gave you everything to work out the gravitational potential energy. Then you've just got to make that leap that will be equal to the maximum kinetic energy. This time, they gave you everything to work out the kinetic energy just as it left. You had to realise that that is exactly the same, that is equal to the maximum gravitational potential energy. Then substitute the values in, rearrange the equation. So again, it's this simple idea. So hopefully that will help you through this.